Hi there, and welcome to today's class. We're going to study of resolution of vector in 2D. Let's look at the concept of resolution of vector in 2D. We'll look at definition of this man, and then we'll look at the concept of resultant. Aside that, I'll also look at some basic concepts you're familiar with when it comes to resolution of vector in 2D, and then from there we'll build up by solving several past questions in the study of resolution of vector in 2D. By definition, resolution of vector is the splitting of a singular vector into two or more vectors in different directions, which when added together give the same effect as that singular vector. Note that single vector which is being splitted is called the resultant vector. So I'm saying that that vector that has been splitted is called the resultant vector. Is called the resultant vector. So what is a resultant vector by definition? A scalar vector is a singular vector that has the same effect in magnitude and direction as two or more vectors acting together. This is how you define resultant vector. So from resolution, we look at resultant, and I've given you definition for what a resultant vector. You said it's a singular vector that has the same effect in magnitude and direction as two or more vector acting as two or more vector acting together, right? That's how you define resultant. At this junction here, we said the word 2D here, the word 2D here means two dimension. The 2D there means two dimension. And the dimension we're considering here is the x and y coordinates. That is, look up please. If I have a graph this way, so this is the x and the y coordinate. So I'm saying this 2D refers to as the y and the x in this form, right? So this is basically the concept behind the 2D of a thing. So the word 2D means we are simply splitting a vector into x and y coordinates, right? So that's basically how this concept works. So I've defined resolution, I've defined resultant, and I've defined the idea behind 2D. At this junction here, let's proceed further. At this point here, we will look at two cases. I'll give you case 1 and case 2. From case 1 and case 2, also look at some several formulas into familiar with, and then we'll solve several past questions in the study of resolution of vector. Now here's the idea. So let's start with case 1.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
Let's start with case 1. Let's start with case 1. Let's start with case 1. Alright. For case 1 here, so let's say I have my 2D vector in this form. For case 1, this is called, let me call here first f of x, let me call here f of y. Let's say I have a force f inclined to an angle theta to the horizontal. Now listen please. I call this horizontal, I call this vertical. Observe that this angle is inclined to the what? Horizontal. That is the f of x. Now here's the task and condition and idea. For easy understanding, here's the concept please. Listen. Anywhere the angle is lying on becomes cos theta. Please listen. anywhere the angle is lying on becomes cos. So look up please. If I'm asked to resolve this, yes I did. I have a force and angle. I want to change a force and angle into vertical and horizontal components. It is called resolution. So I want to resolve this force and angle into a vertical component that is f of y and a horizontal component that is what? F of x. What do you do? Your first priority, let's get f of y. What would be the value of f of x per se? What will be the value of f of x and the value of f of y? So what will be f of x? What will be f of y in this case? Please look up. We said anywhere the angle is lying on becomes cos. Observe that in this case 1, my angle is lying on what? On the horizontal. So it means f of x becomes what? The cos. That becomes the force first. Cos first, then cos theta. Theta is the angle. So cos theta, I have this one here. So if I resolve f and this angle to the horizontal to f of x becomes what? F cos theta. Now, in other words, this f of y becomes f sine theta automatically. So I'm saying this. The reason why I have f of x as cos theta is because the angle is lying on horizontal on the f of x. So f of x becomes the cos theta. While f of y automatically becomes sine theta. And this f is my force here, must come first before you consider the angle. So the force must come first before you consider what? The angle. This is case 1. I'm saying this again. I said anywhere the angle is lying on becomes what? The cos. The angle is lying on what? The horizontal, f of x. So f of x becomes what then? Becomes cos. Why does f of y becomes what? Sine. Now we said always put in your force first before you consider the angles. This is the idea behind case 1. Let's look at case 2.
I just launched my website www.ghanaabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys and welcome to my channel.
Let's do case 2. Let's look at case 2. For case 2, I have this same 2D f of x here. Let me call here f of y, such that I have a force this way, inclined at an angle to the vertical. Inclined at an angle to the what? To the vertical. So look up in this case now. Difference between this and this is that for this one here, the angle is sleeping on horizontal. For this case here, angle is not sleeping on the horizontal. Angle is what? Sleeping on what? The vertical. So it means that f of y. So let's get f of x, f of y. What will be f of x value? What will be f of y value? Observe that the angle is lying on what? The vertical. So it means your force first, as we said, the force should start first. Then we said the angle is lying on what? The vertical in this case, right? F of y. So it means f of y becomes cos. So then becomes cos theta. Here becomes sine theta automatically. So observe my language. The angle is lying on the vertical. So it means the vertical becomes cos. The angle is to horizontal in this case. So it means f of x becomes what? The cos. Why the other one becomes sine automatically. So I'm saying this, anywhere the angle is lying on becomes cos. The other side, the other one becomes sine automatically. This is how you resolve forces in 2D. So for case 1, I have a force, an angle inclined to horizontal. So if you have a force and that force is inclined at an angle to the horizontal, your f of x becomes f cos theta, f of y becomes f sine theta. For case 2, if you have a force inclined at an angle to the vertical, it means that f of x becomes f sine theta, f of y becomes f cos theta. This is how this concept works. So this is the idea behind resolution of vectors in 2D. Let's look at one last important idea so that that will help in the understanding of resolution of vector in 2D. Let's look at one last key important concept we need to know. One important concept we need to know before we proceed to other concepts. So let's look at one important thing to note. Normally, if I have my graph this way, This is x, this is y, this is negative x axis, positive x axis, positive y, and this is my negative y axis. Now, whenever your force or the force and the angle you are resolving, okay, this part is my first quadrant, second quadrant, third quadrant, and then the fourth quadrant. Now, if the force and the angle you are resolving falls under the first quadrant, you take s as positive, y as also what? As positive. So whenever you are resolving force and an angle that is inclined at your first quadrant, if you observe now, this one here is in my first quadrant this way. You can see this way. So it means that f of x will be what? Positive. If I am resolving a force that is inclined to an angle at second quadrant, it means my s will be what? Negative of x. My y becomes what? The positive of y. To number 3 here, to quadrant 3. If I have a force and angle at quadrant 3, if I resolve them, it means my f of x becomes negative x, f of y becomes what? The negative y as the value. Finally, at quadrant 4, if I have a force and angle at this quadrant, if I resolve them, for the x becomes positive of x, here gives me negative of what? Of y. So understand when your f of x is negative, f of y is positive, using this idea of this quadrant concept. At this juncture, let's look at example 1 and see how that works. Before example 1, I would like to give some formulas that we will need in the study of this resolution of vector into the. Welcome guys, I just launched a course. The course will teach you how to start your own YouTube channel. If you're a teacher also trying to do what I'm doing, you can get this course. The course costs about just 10,000 naira. You can get a course and you start uploading your videos on YouTube. Or if you're a beginner trying to explore YouTube and are having interest in learning how this YouTube of a thing works, you can do well to get this course. As you can see the banner of this course in the video, in the screen of the video, right? So do well to go and get the YouTube course so you can earn, learn, and also grow your platform. See you guys. If this interests you, do well to message me up or click on the link you see in the video description that says YouTube course. See you guys in next page. All right. Know the following formulas as we proceed. So know this formula. Know the following formula as we proceed. If you ask to find, resultant, if I have to find the force of resultant or the resultant force, if I have to find resultant force, Fr is equal to summation f of x plus summation f of y. But if you are asked to express it in terms of vector, here becomes I, here becomes j. This is in vector form. But if you're not asked to put it in vector form, erase I and J away. So if you're asked to find the resultant force, the resultant force is Fr, that's summation f of x plus summation f of y. Also, we're asked to find the magnitude of resultant force. In this case, there's a word magnitude here. Magnitude is also known as modulus. So it means that the magnitude becomes, okay, please, in vector form, this gives you this, please. If it is not in vector form, you erase this part, erase I and J. That gives you a normal resultant force. But if I ask to express it in vector form, becomes position vector of F and M, resultant force I and J. Just put this symbol I and J becomes vector form. But if you don't want it to be in vector form, just erase I and J and this arrow. Now, to find magnitude of resultant force, if you have to find the difference between resultant force and magnitude of resultant force. For the magnitude of resultant force, that gives you Fr this way equal to the square root of summation f of x all square plus summation f of y all square. This is how you calculate for the magnitude of a resultant force. Observe the difference between resultant force alone and magnitude of resultant force. So I have this one here. In case in case also to be in vector form, what do? Just put that arrow, this arrow here, and put I and put J. That will not be in vector form. So in vector form, that gives you Fr magnitude equal to the square root of summation f of x square attach I plus summation f of y all square attach a j. This is the vector form expression, right? So this is how this concept works. So note these two formula. Also note, if you are asked to find direction, for direction, if you are asked to find direction, by the word direction under this concept, direction under this concept means theta, angle. So for the formula of theta is given as the tan inverse of summation f of y all over summation f of x. So this is how to find the angle. So theta is given by, so here's the idea. In exam, you'll be asked to find the resultant force alone. Just use this. If you have to find magnitude, listen to the English, magnitude of resultant force, use this man. If you have to find and direction gives you tan inverse of theta equal to summation f of x summation f of y. So this is how. So note this following formula. We'll use them as we proceed in the study of resolution of vector in 2D. Let's solve sample problem 1. Let's do example 1 and see how that can help and see how these formulas can help, and the concept of learned so far can help us with solving the first example.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both, right? So once you join the channel membership for other level student, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
Welcome back. Example 1 says, find the resultant of the force below. Listen, find the resultant, not magnitude of resultant. It was just what? Find resultant. What do we know? We said for resultant of force, right? That's Fr is equal to summation f of x plus summation f of y. In case you are asked to put it in a vector form, what do? Put an arrow here, and then I should be here. You have j at this point. This is it in vector form. We said this earlier. Now, to get my resultant force in this case, I need two things. I need f of x, I need f of y. First, f of x means force acting on the horizontal axis, right? So f of x means, or summation, this means summation of f of x means force acting on the horizontal axis, while f of y means force acting on the vertical axis. All right. So this is like the definition for each of the expression f of x and f of y. So first, we'll look for f of x, something of x, and something f of y. Boys are there. Now I'm having look. If you look at this part here, we said note this idea I told you earlier that if I have a graph this way, we said for this first quadrant, we said x should be positive, y should be positive. For this quadrant, we said x should be negative, y should be positive. This quadrant, we said both x and y are negative. Here we said x is positive, y is what? Negative. Now, which quadrant does this force and angle fall? The force and angle fall under what? Under this first quadrant. It means both f of x, f of y will be positive. So let's resolve this. What's the f of x here? What is the f of y in this case? So let's look at the first one. Let's look for summation of f of x. Let's look at summation of horizontal component. That's your f of x, f of x. In this case, what will be f of x? We said the value should be positive because it has third quadrant. So f of x is positive answer. So my answer should be positive. But is like there. Observe that here, this part here is my f of x. Here is my f of y. If I resolve f of x, what will f of x be here? We said the angle is lying on the horizontal. It means if angle is lying on the horizontal, this one becomes cos. So take the force first. The force first, that gives you 20. The force first, then perhaps that gives you 20. 20 Newton means force. So that will become F cos theta. If you check your notes, when we had case 1 was sort of this nature. The f of x for case 1 was F cos theta, right? So in this case, my F becomes 20. 20 cos theta in this case is 30. So 30. So it means that f of x, summation of force on the components, f of x gives me about, if I punch into the calculator, I have 17.32. 17.32 of course in Newton. That's f of x. Perhaps you can x for x axis, you add I because I is for x in vector form, right? So let's look at summation of vertical components. That's f of y. F of x is f cos theta. So let's look at summation of vertical component. That's f of y. So f of y will be equal to what? If f of x is f cos theta, it means f of y becomes what there? F sine theta. F is 20, then sine theta is 30. So what will be f of f? F of y? F of y will be equal to 20 sin 30. That gives you 10. Of course, Newton. If it's y, that gives you j in vector form. So we have looked for f of x and f of y. For my first quadrant, the two are positive. That's why I have a positive value here and a positive value here. So I have to find the resultant force. That gives you resultant force Fr equal to summation f of x plus what? Summation f of y. From here, let's get resultant force. From here, let's get resultant force. From here, resultant force is equal to f of x. F of x gives you, now yes I there. In this system, it was just f and 30 degree, 20 here this way. It was just in this system here. I have just only one force and angle. So instead of me using summation, I will have used horizontal component and vertical component, because summation is used when you have many or you have more than one f of x. In this case, I have the only, if I resolve this one here, I have only one f of x and one f of y. So instead of using summation, I should have used what? Just horizontal component and vertical component, but it's still you can still use summation. But I'm saying that summation is used when you have more than one f of x, more than one f of y in a question. In this case here, my f of x is just one value, f of y is just one value, right? So instead of me, I shouldn't have used summation, but let's go with it this way. Now f of r, f of x gives you, f of x is what? This value here. That's 17.32 Newton I plus, for f of y, that gives you plus 10, of course, plus 10 Newton J. At this junction, this can be expressed as 17.32 I plus 10 J. Then the Newton should be outside this way. So my f of r in terms of vector becomes this value. This is how you find the resultant force for this question. All right, so this is how this question work. So here's the idea. This value here is my answer for resultant force. But we have to find magnitude of resultant force. For instance, let's look for magnitude, for instance. So let's look for magnitude of this resultant force. That becomes magnitude of resultant force equal to what? Square root of summation f of x all square plus summation f of y all square. This one gives you square root of f of x. This value, f of x is this value. So that's 17.32 all squared plus f of y is this value 10. 10 squared. Let's get magnitude of f of r. That's resultant force. So f of r, sorry, is equal to, if I punch 17 points, if I punch 17.32 all squared, that gives about square root of 298.42 plus 10 squared gives you 100. By the way, I'm not put to look for magnitude. I'm just showing you in case. The question says we should find resultant force, not magnitude of resultant force. So I should have stopped here. But I want to show you in case you have to find magnitude, what do? Just take the magnitude this way and then solve this way. From here, let's get magnitude of resistance force. That gives you magnitude of resistance force is equal to what? The square root of, add these two together, that gives you 398.42. So the magnitude of resistance force will be equal to, take the square root of the value, square root of 398.42. That gives me 19.96 Newton. So the magnitude of the resonant force Fr is equal to 19.96 Newton, right? So let's say again, let's say that you are asked to find the direction here too. If you are asked to find direction, what do you do? For direction, that's the angle theta. The angle theta. So let's assume you are asked to find direction. What do you do? So for direction, that theta is equal to what? Tan inverse of summation f of y over summation f of x. That gives you tan inverse of f of y is of course 10 all over f of x, of course 17.32. This gives you tan inverse of, divide 10 divided by 17.32. That gives about 0.577. So theta will be equal to tan inverse of this value, tan inverse of the value 0.577. That gives about 0.650 degrees. All right. So this is how you find the direction, the magnitude, and the resultant of this question. So we were only asked to find the resultant, but I go extensively by looking for the magnitude and the direction. So this is how this concept works, right? All right. So let's proceed, please. Let's proceed from here. So let's do another example under the study of the resolution of vector in 2D.